Alright, so today I'm going to make a short videos about the gradient and area under the graph. Because this topic, I recently actually I received quite a lot of requests about this topic, so I decided to make one, to make students actually understand about this topic, because I personally think that this topic is quite easy, but then maybe some students just cannot understand. So I'm going to make a short tutorial, and then I will actually include two hot questions. I hope actually can help you. All right, for gradient area under the graph, basically you have two type of graph. One is the distance time graph, the other one will be speed time graph. All right, so just let me sketch out the graph. Okay, let's say I have two exactly the same graph. Okay, so I'm going to call this one is time, and this one is distance, and this one is speed, this one is time. Right, so basically I just randomly sketch the graph because I just want to make sure you can understand it. So you just assume both of them is actually exactly the same, because I hope you actually can differentiate it. So this is how I do it. Okay, let's say I randomly will give it some value. Same to here also. Let's say over here will be 12. This one will be 12 also, and this one will be 5, and then this one will be 10. Maybe this is 12. Right, this one will be 5, this one will be 10, this one will be 12. Right, so first thing is you have to understand the concept first. Okay, so first thing is I say about the gradient. Okay, gradients, whenever I say about gradient, you understand gradient actually equals to m. If you learn about straight line, you know gradient actually equals to y2 minus y1 over x2 minus x1. So in this topic, what is the meaning for gradient? Okay, in this topic, if you see the distant time graph, this one will consider gradient. Okay, this one is actually the gradient, and the gradient for distant time graph is the speed. Right, so this is also the gradient, so this one is actually the speed also. Okay, but the gradient for speed time graph, actually is acceleration. But then in this topic they just don't like to use the word acceleration, so you always will see something that call it rate of change of speed. Rate of change of speed basically is acceleration. Okay, means like actually increasing the speed. Over here is something like decreasing the speed. Okay, but then for distant time graph, the speed over here it doesn't mean increase or decrease. All right, the speed over here is just mean constant speed. All right, so let's say in this case, let's say the question asks you to find the speed in the first 5 seconds. So the question asks you to find the speed for first 5 seconds. So what you can do is basically you will need to find the gradient in the first 5 seconds. In order to find the gradient, basically I will need two coordinates, isn't it? I know this coordinate is called 5 and 12, and then over here this is called 0, 0. So I can easily get the speed in the first 5 seconds, because over here is first 5 seconds. So I'm going to use 12 minus 0 over 5 minus 0. So my gradient basically is 12 over 5. I mean my speed actually equals to 12 over 5. Okay, but then sometimes the question actually they love to like twist the question a little bit, and then it loves to actually say something like this. Find the speed for last 2 seconds. So in order to find the speed of last 2 seconds, you understand basically last 2 is from 10 to 12 over here, doesn't it? So in order to get the speed, same thing, I will actually use the 2 coordinate over here, and then this one basically is just 10, 12, and over here this one is just 12, it's just 12, 0. And then y1 minus y2 over x1 minus x2. So it's just 12 minus 0 over 12 minus 0, 10 minus 12. And then basically for this one, you will get negative value because bottom is negative 2, and then you will get negative 6. And in this case, you can ignore about the negative. Okay, but then of course the negative do mean something, but then the negative over here, it doesn't mean decreasing the speed like 6 constantly. The negative 6 here, actually this one means going backwards. It's actually mean going back to origin, or you can say they're actually going backwards. Right, so okay, so if you want me to actually make some example, first of course you have to understand the constant also. Do you find out let me choose some different color, or maybe it's blue. Okay, do you find out here actually the constant value? When I say constant value, it actually means it must be parallel to x-axis. Then we call it constant. Whenever the things is parallel to x-axis, we call it constant. So the constant for the distant time graph, they call it stationary. Stationary. In other words, basically the particle is just stopped there. Alright, but then the constant for the speed time graph is not the stationary. The constant for the speed time graph basically means constant speed. Means the car actually, or the particle actually doesn't increase or decrease the speed. Maybe the car is keep the 12 speed per second, 12 meter per second for 5 seconds. Means it keep the constant speed. Means it continue drive 12 until 10 to 12, then it actually decreasing the speed to 0. Right, so okay, let me like I make a quick summary about this one. So for distant time graph, if the graph is look like this, I can understand actually. Okay, it's something like this. Let's say the origin is your home, and then okay, from home here, you actually travel 12 meter to your school, and then you're going to stay at the school for okay, let's say this is hour lah. Then it's easier for me to explain. You're going to stay in school for 5 hours. After that, you're going back home. Because over here, you distance back to 0. When you distance back to 0, basically mean you're going back home. So it's something like, okay, so you're from home, and then you drive with this speed, 12 over 5 is, or you can call it 2.4. You drive with a constant speed, 2.4, until you reach the school. And then the school, from your home to the school basically is 12 meter or 12 km. Okay, let's say this is km, we're going to call it 12 km. Okay, then you're going to stay in your school for 5 hours, because over here your speed actually is 0, because your speed never change. It's continuous. 12 means your speed never change. That means you actually because the question, the exam actually love to ask about duration, about stationary. So you just say 5 seconds or 5 hours. Then over here is you used another speed, which is like 6. Actually you drive faster. You use the speed of 6 actually going back home, because you're going back to the 0. 0 here actually is your home. Alright. But then for the speed time graph, it's totally different cases. This is something like this. A particle actually increasing the speed. Of course the rate of change of speed is over here is the same value of this one, is 12 over 5. It's 12 over 5. Or you can call it 2.4. So that means every second the particle actually increase the speed is 2.4, 2.4, 2.4, 2.4, 2.4 until the 5th second the particle actually reach the speed of 12. And then the particle keep at the same speed for 5 seconds. And then the particle actually decrease the speed to 0 using 2 seconds. So if you ask me about rate of change for last 2 seconds, it's going to be -6. That means the particle actually from 12 here, every second the particle actually like decrease 6 speed. This is how they change the speed. So 2 seconds actually he go back to the 0. So then the particle actually will going to stop here. Alright. And then another very big difference between distance time graph and speed time graph is something like the meanings of the area. For both of these diagram, only the speed time graph, the area do have the meaning. That means for the distance time graph, the area do not have any meanings. But then for the speed time graph, the area actually means distance. Actually means the distance traveled by the particle. Alright, so actually, okay, so if one of the most common question is actually, the question actually love to ask you about average speed. In the exam, you always will see something that to do is average speed. Average speed means you have to do something with total distance divided by total time. So, if in this case, I want to get my total distance travel for the, let's say, first 12 seconds. So what I need to do is, I will need to find the area of the trapezium. So my area of the trapeziums over here is basically is half, and then this 2 is parallel line, right? So this one is 5 plus 12, bracket 5 plus 12, and then multiple the height is 12. Okay, this is how I find the area, and then divided by total time, which is 12 seconds, just like this. However, if I want to do the average speed for the distance time graph, okay, so in this diagram, actually you travel to the school, you use 12 meter, and then you're going back, you use 12 meter. So the total distance for you is basically is 24 meter. Do you find actually is 24 meter, and then you use 12 seconds. So if I want to find the average speed for this case, which I'm going to erase this one first, if I want to find the average speed for this case, I'm going to use a total distance. Total distance is going to be 12 plus 12, because this is distance. Your y-axis is distance, so it's going to be very easy. Just 12 plus 12 divided by total time, 12. So this is 24 over 12, and then your average speed is basically is 2 meter per second maybe. Okay, so this one, of course, you will need to solve it, and then you basically, yeah, you can cut, and then you will get 17 over 2, which is 8.5. Yeah, your average speed is 8.5 km. Meter per second. Okay, this is something you have to understand about these two diagrams, because they are very big difference. But then, if in terms of exam, which one is more famous, I would say speed time graph. If you actually going through all the past year, you will find out the chances of actually coming out is speed time graph is very high. It's almost something like 8 out of 10. So if you want to do revision, actually you can pay more attention on the speed time graph. But then as a teacher, of course, I hope you can understand both diagram very well. Okay, so please, whenever you have the distance time graph, you never use the area to find the distance. This is one of the common mistake made by a lot of students. Alright, and then you also need to understand what is the meaning of the gradient for the distance time graph, and what's the meaning of gradient for the speed time graph. The gradient for distance time graph actually means speed. The distance, what am I saying? I mean the gradient for distance time graph actually means speed, and the gradient for speed time graph actually means rate of change of speed, or you can call it acceleration, or you can call it increase of speed. Over here you can call it decrease of speed. Okay, there's few name, and then the constant for distance time graph actually means stationary, mean the particle doesn't move at all. The particle actually stop there. And then the exam love to ask about how long actually the particle stop there. You just use 10 minus 5, and then you know it's 5 seconds. Okay, but then for the speed time graph, the constant over here doesn't mean stop. The constant over here actually means the particle actually keep at a constant speed, move for 5 seconds. Alright, because sometimes the exam actually will ask about find the distance travel of the particle for their constant speed. So that's mean the question actually want to know how far actually the particle is travel in the constant speed. So it basically you need to find the area of rectangle, so which is 5 plus times 12, which is 60 meter. Okay, this is how the question can be tricked. Okay, so yeah, in order to end this video, I'm going to like bring out two example. It might consider is slightly hard one. Of course, the easier example you actually can try to do it yourself. If you can't understand, just let me know and I will try my best to help you. Okay, so yeah, so over here, let's have a look on the first question first. Okay, so for these questions, yeah, you will see this is speed tie graph. So is in this speed tie graph, so over here, this is all the unit of the speed. Okay, so you have 6, 12, and 20, and all over here it's actually is the time. And then of course, in order to make this question is going to make this question harder, the exam definitely will give you some unknown over here. And then the purpose of it is just to trying to make this question look harder. Alright, so okay, so this is a unit, this is second, this is meter per second. Alright, so from here, the first A, he asks you to calculate the rate of change of speed in the first 4 seconds. So whenever I say first 4 seconds means from 0 to 4. This is first 4 seconds. That means in the part A, the question actually wants to find the gradient. Because I say the rate of change of speed actually means gradient. Actually means the gradient. So that means I want to find the gradient for the first 4 seconds. Definitely I will take two coordinates on the graph. So the first coordinate over here, this one is basically is 4, 12. And the second coordinate over here, basically this is 0, 6. Oops, sorry. I'm going to move this one. It's fine. This one is just it's a 0, 6. So yeah, okay. Actually, I accidentally pressed the graph. So this one will be 0. Okay, it's quite hard to write there. It's fine. So I'm going to do the gradient things here. So gradients basically, one of the coordinate is 0, 6. The other coordinate is basically 4, 12. Alright, so in order to get the calculates, oops, this is ridiculous. Okay, let me erase the thing first, and then let me actually adjust the things. Okay, I'm not sure how actually it can is work here, because this is first time I use this software. And anyways, okay, so in order to get the rate of change of speed in the first 4 seconds, I just need to take these two coordinates and then I just find the gradient. So I'm going to use 12 minus 6 over 4 minus 0. Then you can get 6 over 4, and which is 3 over 2, and then you can say the rate of change of speed is 1.5 meter per second square. Alright, so this is how we do the unit, meter per second square. Okay, it's because it's basically you are doing something like you actually, in order to get rate of change of speed, basically you are using meter per second over second. So divide second again, so you got meter per second square. Okay, this is for acceleration, which is rate of change of speed. Right, for the second part, the question actually asks you state the uniform speed of the particle. State the uniform speed means the question want to know what's the uniform speed in this particle. So obviously the uniform speed is a constant here, because I say only here they are parallel to x-axis. So the constant here is just 20. So over here, B, you just write 20 meter per second. Alright, it's just 1 mark question. Then we go to C. Okay, C is which I think you will get most mark over here, 3 to 4 mark. Calculate the values of K given that the total distance traveled by the periods of K second is 132. So that means this is something quite important. Is something like total distance traveled by the periods of K. That means the question doesn't want you to find the area of the whole diagram. The question only wants you to find the distance from 0 to K. That's all. That means I will need to find the area of this trapezium and then plus together with the area of my second trapezium. So basically I will need to find both of the area of trapezium, and then I'm going to sum them together, and then I will make them equals to 132. then I solve the equation, and then I will get my value of k. So okay, so since the distance, I'm going to say distance equals to 132, and then I'm going to do the first one. It's just half a plus b. A and b is two parallel line. This is 6 plus 12. 6 plus 12 multiple the height, which is 4. Okay, this is the blue color one. I plus my purple color one, which is another distance. So distance, so it's still the same, half a plus b. Over here is 20, over here is 12. So I'm going to say it's 20 plus 12. Okay, multiple the height. The height over here, this is something is very crucial. Should you put k or should you put 4, or what value you should put? So basically this is k minus 4. The distance from here to here basically is k minus 4. How I know it's actually called k minus 4? Assume k is 10 or assume k is 8. How you actually find the distance here? You're going to use 8 minus 4, isn't it? So this is how we actually get the height here. So if this k is 8, you're going to use 8 minus 4. So if k is k, you just use k minus 4. Alright, so the distance here is going to be k minus 4. And then close bracket. And I will highly recommend you to put the bracket for k minus 4. If not, if you write like this, it seems like you only multiply with k. Alright, so you must very be careful. Equals to 132. So if I can solve this equation, basically I can easily get my value of k. So I'm going to scroll down a little bit, and I'm going to solve this equation. So I'm going to simplify it, become 2. This one will be 18 times 2, which is 36. Plus this one, over here, sum together is 32. 32 is simplified with this one, I get 16. So at 16, I'm going to multiply for both. So this one will be 16k minus 64 equals to 132. And then definitely over here, I can minus first. So it's 64 minus 36. Let's say, just lazy to use calculator. This one will be 4, will be 8. So it's basically it's 28. So this one minus this one, you get negative 28. So 16k minus 28 equals 132. So 16k is basically plus 28, which is 160. Alright, so yeah, so k is just 160 divided by 16, and then k you will get 10. Okay, this is how we find the values of k if that one is given is unknown. And then most of the time, if I can get my value of k, what I will do over here is basically I will try to substitute my k back into diagram, see whether it makes sense or not. If k equal to 10, 10 is bigger than 4 is less than 14, so it makes sense. So k is going to equal to 10. So for example, if k you get 15, you know your k is something wrong, because over here is only 13, k cannot be bigger than 13. Or k you get 2, you know it's wrong, because k should be bigger than 4 based on the logic of the diagram. Alright, so okay, one last question before I end this video. Let's have a look on this one. Okay, over here basically you will see a diagram here, and then this is speed time also, because normally the hot question is coming out from the speed time. Okay, so find the average speed for the first 6 seconds. This one is a bit tricky because average speed is not the speed. Average speed, just now I just say average speed basically equals to total distance divided by total time. So in order to get the total distance for the first 6 seconds, which is from here, 0s to here, we call it first 6 seconds. So basically you need to find the area of this triangle, because this is speed time graph. The only way you can get distance is to find the area. So I'm going to use a triangle formula, which is half multiple base multiple height. So we're going to divide it by total time, which is 6 seconds. Okay, simple. Then I'm going to simplify with this 18 is easier, 9, and then 6 and 6 I can simplify. So the average speed basically is 9 meters per second. Okay, this is how we solve A. Alright, then we go to the B. B basically is a bit tricky. So the question says calculate the values of t if the first one, and then calculate the values of t if this one. So basically for part 1 and part 2, basically you will get 2 different values of t. This one is the first thing you have to understand about this topic, because some students might think the part 1 answer is related to the part 2, but then in this case it's totally not related. Alright, so let's solve about the first one. Okay, first one, the question says the rate of decrease of speed is twice the rate of increase of speed. That means when I say rate of decrease of speed, obviously the question is saying about this one, is how to decrease the speed. So the question say that, let's say the rate over here is x, and then it says it's twice the rate of increase of speed. So let's say I say this is rate of increase of speed because speed is keep on increasing. So let's say I call this one as y. So based on this sentence, I know basically x is equals to 2y, because the question says the rate of decrease of speed, which is this speed, is twice, is double, or is 2 times the rate of increase of speed. Okay, this is some logic about part 1. Okay, so first thing, in order to get rid of change of speed, you know this is gradient, so you're going to use the gradient formula. So in order to use the gradient formula, basically you will need to have 2 coordinates. The first coordinate here, this one is basically is just t and 0. Oops, same question, same problem again. Okay, this one is just, I guess, is there any way I can write? Oops, 0. Okay, maybe I shouldn't press too long. Okay, and then this one is just basically in 6 and 18. Okay, and then for this coordinate is just 0, 0. Oops. It's just, okay. It's a 0, 0. Okay, doesn't let me write 0, 0, but then at least I know it's 0, 0. Okay, so what I will do is I will actually find the x value first. So it's quite simple. I use 8. I'm going to use 18 minus 0 over 6 minus t. Is equals to twice, so I'm going to use 2 multiply this one. This one is 0, 0, isn't it? So I'm going to 18 minus 0 over 6 minus 0. 18 minus 0 over 6 minus 0. So yeah, of course I will need to solve this one. It's just simple, 6 minus t. And over here, this one is 0, 0, you can cancel because minus 0 it doesn't change it. Over here it's going to be 3. So yeah, it's 6. 2 times 3 is going to be 6. Then I'm going to solve this equation. 18 equals to 36 minus 6t. And then I'm going to bring over here. So 6. Oops. If you do like this, you might got some mistake. And then I just realized I did a mistake also. Okay, because what I'm doing here is, because this speed actually is decreasing. When this speed is decreasing, I believe you should have a negative value for your x, because it actually is decreasing. What the speed is decreasing, you might have the negative. So I believe you have to add a negative over here. Okay, so then only I continue to do. So yeah, I'm going to make the 60 to the other side positive 60, and 18 to here we're going to plus 18, and then it's going to be 54, and then t is actually 9. Okay, because if you didn't add the negative, you might get your t value actually is smaller than 6. Okay, actually you can see 60 and move here equivalent 18, but then a t actually is 3. Then yeah, you might get this question wrong. So yeah, this is something you should pay attention at. And the second one is quite simple. The total distance traveled is 99 meter, and then you want to get t. Then this one is quite simple. Oops. Okay, let me, because this is new apps, and I find it's actually quite difficult to use. Yeah, I prefer to use those apps I used before. Anyways, let me just finish this one. So the total distance is 99 meter. Basically, total distance, actually is the total area of the whole triangle. So we do not know what is the t here. So since the question says the distance equals to 99, so what I will do is I can easily get the distance, the area of triangle. It's just base which is t, multiple the half multiple base multiple height. So we're going to half multiple base multiple the height, which is 18, and I get 99. And then I'm going to simplify, I get 9. Then my t is just 99 over 9. My t is just 11 seconds. Right, this is how we solve the speed time questions or the distance time question. Is it distance time question? I find out it's quite simple. If you do have any distance time question you find out it's quite hard, you just let me know. Maybe I can make a video for it. Anyways, I think this video is quite long. I hope actually it do help you to understand better about this topic. Alright, anyways, thanks for watching.